Hello my dear students, welcome back to my channel Essential Academy Chemistry with Vinay. In this video, we are going to solve the questions that is based on aromaticity. There are some simple tricks to solve the questions that is based on the aromaticity, where before solving the questions, first let us understand what is aromaticity, what is anti-aromaticity, and what is non-aromaticity. If you know this, what is being shown to you, if you know this, you can easily solve all kinds of questions based on aromaticity, anti-aromaticity, or if it is a non-aromaticity. Now, let us understand what is aromaticity. In aromaticity, if you observe, here we have a 4n plus 2 plus a continuous resonance. 4n plus 2, you might have heard, that is a Huckel rule. So, if I substitute in this n 0, then the value is going to be 2. If I substitute in the place of n 1, the value will become 6. If I substitute 2, it becomes 10. If I substitute 3, it becomes 14. Like this it goes on. If any of the molecule, if it follows these number of pi electrons, when you count the pi electrons, if these are the number of pi electrons, then you can easily follow that it is following aromaticity. Not only the pi electrons, it should also show a continuous resonance. If it shows a continuous resonance, at the same time, if it has got the number of pi electrons in these numbers, then it is following aromaticity. I know that children, you will understand it still better when we solve the questions. When it comes to anti-aromaticity, you can observe here we have 4n plus a continuous resonance. If you substitute 0 here, it becomes 0. If you substitute 1 here, it becomes 4. If you substitute 2 here, it becomes 8. If you substitute 3 here, it becomes 12. If the number of pi electrons are these numbers and it is also followed by a continuous resonance, then that molecule or that compound is going to be showing anti-aromaticity. If the molecule or a compound does not follow any of the above two rules, then it is going to be non-aromaticity. Children, where here you need to remember certain important rules, which is very important, children. The rule number 1 is that we have to count the electrons of only pi bond electrons. If there is a negative charge, then again we have to count the lone pair of electrons. But if there is a positive charge on the compound, we should not count the electrons of it. We cannot count the electrons. Only the electrons of pi bonds, only the electrons of the negative charge on the compound should be counted, but not the electrons that is present in the positive charge on the compound. Hope you have understood. We'll make this use of this complete chart again and again, and let us start solving some of the questions now. Let us solve some of the questions one by one. Let us first solve the easy questions for you. Let us solve the first easiest question. Let us select this example, children. If you observe in this example, you know that it is a benzene ring. Now let us know whether it is showing aromaticity, whether it shows anti-aromaticity, or whether it is a non-aromaticity. Let us start now. First, you can observe here in the rule we have given important rule, count the electrons of pi bonds. So if you observe, in one pi bond there are 2 electrons, 1, 2, 3, 4, 5, 6. So there are totally how many? 6 electrons. So there are totally 6 electrons. When there are totally 6 electrons, where is 6 electrons here? The 6 electrons is here. That is going to be, it is following aromaticity. With the 6 electrons, it should also follow a continuous resonance. How to find out whether it is following a continuous resonance, we can easily just let you know that. What is this continuous resonance? In this continuous resonance, children, if you observe, there is a double bond, single bond, double bond, single bond, double bond, single bond. If there is a continuous double bond and single bond alternatingly double bond, single bond, then there is a continuous resonance. A double bond, single bond, double bond, single bond, double bond, single bond, double bond. Yes, there is a continuous resonance. Therefore, this molecule is showing aromaticity. Next one, we'll go for the next example. In this example, if you observe, first count the number of pi electrons. 1, 2, 3, 4. If it is 4 electrons, you can observe here, it is 4 electrons, it is showing some anti-aromaticity. Let us see whether it shows a continuous resonance. A double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond. Yes, there is 4 electrons and there is a continuous resonance. There is a continuous resonance. Therefore, it is anti-aromaticity. This molecule is showing anti-aromaticity. Let us see the next example. First, let us count the electrons of pi bond. 1, 2, 3, 4. If it is 4 electrons, it is showing towards the anti-aromaticity. Now let us see whether it follows a continuous resonance. If it has the electron and also the continuous electron, then only it will be anti-aromaticity. Let us see that now. Here there are 4 electrons plus a double bond, single bond, single bond, single bond, double bond, single bond, double bond, single bond, single bond, single bond. Therefore, there is no continuous resonance. Therefore, here there is no aromaticity, non-aromaticity. I hope you have understood the first 3 examples. Let us go for the other examples now. If you observe here, children, there is a pi electron here, 1, 2. So the number of electrons are 2. So if it is 2 electron, you can observe here, if it is 2 electron, you can observe it is showing aromaticity. Now let us see whether it has got a continuous resonance. Always remember, whenever there is a positive charge, you just take it as a double bond. You just make that as a double bond. This is the trick that you should remember. Now you can observe here a double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond. Yes, there is a continuous resonance. There is a continuous resonance. According to the rule, we have to count only the electrons of pi bond. If you observe here, I have given here positive charges there on the compound. Do not count the electrons. Do not count the electrons. If you do not count the electrons, then we will count only the electrons of this. That will become 2. If it is 2, then it is showing what? Aromaticity. This compound is showing aromaticity. 2 electrons are here. And what is here? Double bond, single bond, double bond, single bond. Whenever you see a positive charge or a negative charge, you can just write them as a double bond. Let us see one more example. 1, 2, 3, 4. I have already told you in the rule, you can also count the electrons of a negative charge also. 2 electrons here, lone pair of electrons. Here there is a lone pair of electrons. 1, 2, 3, 4. There are 4 electrons. Remember, whenever there is a negative charge, whenever there is a pi bond, count the electrons. So if it is 4, where is 4? Sir, 4 is in anti-aromaticity. 4 is in anti-aromaticity. Let us see whether it shows a continuous resonance. Whenever there is a negative charge, just consider it as a double bond. Double bond, single bond, double bond, single bond. Double bond, single bond, double bond, single bond. Yes, there is a continuous resonance. It is showing anti-aromaticity. It is showing anti-aromaticity. Let us see the next example. Only pi electrons, pi bond is there, 1, 2. But there is no continuous resonance, double bond, single bond, single bond, double bond. There is no continuous resonance. Therefore, no or non-aromaticity. Hope you are understanding better as we are solving more and more number of questions. Let us see for the next one what we have here. In this example, if you observe the number of pi electrons 1, 2, 3, 4. 4 electrons. Plus, let us see whether it follows a continuous resonance. Whenever there is a positive charge, just consider it as a double bond. Double bond, single bond, double bond, single bond, double bond, single bond, double bond. Double bond, single bond, double bond, single bond, double bond, single bond, and there is again a double bond. Yes sir, here this double bond will be taken over here. This comes to this side. A double bond, a single bond, a double bond, a single bond, a double bond, a single bond. Yes, there is a continuous resonance. If the number of electron is 4, if the number of electron is 4, so where is 4? Sir, 4 is here. 4 is here. If the 4 is here, if it is 4, then anti-aromaticity. There is a continuous resonance also. Therefore, it is showing anti-aromaticity. Look at here. 1, 2, 3, 4, 5, 6. Whenever there is a negative charge on the compound, you need to count that electrons also. So there are 6 electrons. Then this becomes a double bond. A single double bond, single bond, double bond, single bond, double bond, single bond, double bond. Yes sir, there is a continuous resonance. If the number of electron is 6, if the number of electron is 6, then it is showing aromaticity. It is also showing a continuous resonance. Remember children, with this electron, it has to show continuous resonance. Then only it shows aromaticity. With this 4n, it also has to show continuous resonance. It has to. Then only it will follow anti-aromaticity. So here 6 is there, a continuous resonance is there. Therefore, it shows aromaticity. We'll go for this one. There is only 2 electrons. Yes sir, 2 electrons. There is no double bond, single bond, double bond, single bond is not there. Therefore, there is no continuous resonance and it is going to become non-aromaticity. Hope you have understood the questions that you have been solved based on aromaticity. Hope this video has helped you to understand aromaticity, anti-aromaticity, non-aromaticity. For more videos, subscribe to my channel, children. If you have any comments, if you like this video, do just click on the like button. For more videos, do subscribe, and I'll be trying to come with some more videos, very interesting ones, so that it helps for your all kinds of entrance examination. See you again.